In this video, we'll be wrapping up our series on binary operation by looking at the inverse identity or inverse property. Now, in an earlier video, we started looking at the concept of binary operations. We were able to look at how to solve basic questions involving binary operation. Then we looked at the first property, which is the closure property. Thereafter, moving on to talking about the commutative property. We also talked about the associative property and distributive property. And in the previous video, or in the last video, we talked about the identity element. So this time around, we want to talk about the inverse identity, or sorry, the inverse property. Inverse property. Now, what does it mean, inverse property? So we are told that an element, A inverse, if, of course, A inverse is an element of R, being R being the set of real numbers. And I thought that the element A inverse will be called the inverse of A if A itself is also an element of R or a member of R. Under the operation star, if A star A inverse or A inverse star A will be equal to the identity element. What does this mean, or what do we mean by this? We're trying to look at a number that we can combine to another number that gets us the identity of that first number we've combined it to. Remember in the previous video what we talked about the identity element, we said for addition, the identity element of addition is 0. So let's say we have 5, and then I want to add 5 to a certain number in such a way that I'll be having 5 at the end. So what do I need to add to 5 that gets me exactly 5? We said 5 plus 0 gives us exactly 5. And that means 0 has to be the identity element of 5. Now, if this is true, for us to now have the inverse, we're now saying what do we need to combine to 5 that gets us this identity element? That is, I want to add or subtract something, and then I want my answer to be 0. Remember, 0 is already the identity element of 5. So what do I need to add to 5 that gets me 0? So of course the answer is negative 5, because 5 plus minus 5 becomes 5 minus 5, and then this will be equal to 0. So we're now saying that this minus 5 has to be the inverse of 5. We also took another example where we use multiplication. We said, let's say we have 5. What do we need to multiply 5 to get us 5 itself? And then we say it was 1. So definitely, if I want to multiply 5 by a certain number to get the identity element, which is 1, so what do you think the number has to be? Again, the number will just be the reciprocal of 5. So 1 over 5 has to be the inverse of 5 itself under multiplication. So underneath this, we simply want to find the inverse of an element or a member. So how can we find the inverse of a member? From the definition, we're already told that A star A inverse or A inverse star A must be equal to the identity element. So definitely, it must mean that we have to first of all find the identity element if we are not given. So if we are not given, then the first step will always be to find the identity element. And then after finding the identity element, we can now find its inverse itself. I know how do we find the identity element? So we simply said A dot E must be equal to A. So this is how we find the identity element. And then to find the inverse, we're going to come and be using anything from this property we've written here. Okay, so let's look at a more refined example so we can set this in once and for all. So for our first question, we're told that an operation star is defined on a set R of real numbers by A star B equal to A plus B minus AB, where A and B are all elements of the set R. Determine the inverse under star of a general element A being an element of R. So we have to find the inverse underneath this. Then Roman figure 2, we have to state the element of R which has no inverse. And Roman figure 3, we have to find the inverse of 5. So without wasting much time, so we want to write two things. There are two things that should always come to our mind when we're looking for the inverse. The first one should be A. So the operation we're dealing with is star. So A star, A inverse. Now, the fact that I've written A star, A inverse, I could as well have written it as A inverse star A. So it doesn't matter. So which one you want to do, pick one and then stick with it. So this time around, we want to stick with this A star A inverse. And we know this will be equal to E, where E is the identity element. If the question had given us the identity elements here, we will have come to use this. But because the question didn't give us the identity element, then we want to write one more equation and then we can be on our merry way to solving this question. So what's the equation? So we already know that A, again, the operation we're dealing with, A star E must be equal to A. So first of all, we're going to use this to find our identity element. And then after finding our identity element, we'll come and use this to find the inverse of our element. All right, so for the first one, for question one, so let's find our identity element first. So you can see the operation A star B, A star E. So anywhere I see A, I will use A. Anywhere I see B, I will use E instead. So this becomes A plus E minus AE. So this is equal to A. A plus E minus AE equal to A. Now, how do I find the identity element? So by simply taking A to the other side. So this becomes E minus AE is equal to A minus A. And A minus A gives us 0. So I have, so factorizing this, I have E 1 minus A is equal to 0, and dividing both sides by 1 minus A. So I have my E is equal to 0. So I'm done with the first part. So for the second part is now to find the inverse, A inverse. Remember, that's what we have to determine the inverse under star of a general element. Now, first find the inverse, then I have to write this. So I have to write the second expression. So here I have A star A inverse is equal to, so there's no point writing E again since I already know the value of E. So E here is 0. Okay, so now go back to the question. A star B, you can see this looks like A star B. So anywhere I see A, I'll still write A. Anywhere I see B, now I'm going to write A inverse. So I'm going to write it as A plus A inverse minus A times A inverse. Okay, so A plus A inverse minus A times A inverse. So this must be equal to 0. Okay, now I want A inverse to be the survey formula. So firstly, I need to carry A to the other side. So carrying A to the other side, I'm left with A inverse minus A times A inverse has to be A and A inverse. That is A dot A inverse. So this is equal to minus A, because by the time I take A to the other side of the equal to sign, it becomes negative. Now the next thing to do here is to factorize. Factorizing this, I'll have A inverse will be equal to, sorry, I said equal to, so it should be in the bracket. A inverse in the bracket of 1 minus A. So this is equal to minus A. And lastly, my A inverse has to be equal to minus A. So I divide both sides by 1 by A. So that becomes 1 minus 1 minus A. So this is my A inverse. So this is the answer to the first question. Now for the second part of the question, we have to state the element of R which has no inverse. We have to state the element of R which has no inverse. Now, anytime you have asked to mention or state the element of a particular value that has no inverse, that is, the first thing that should come to your mind is function. Remember, underneath function, we looked at a concept where we talked about the largest possible domain of a particular set. So, for what value won't the set have an answer? So that's what they are trying to tell us. So this inverse here, we want to look at the element of R that will have no inverse at all, and that should tell us, because this is a fraction, then we look at the denominator. Remember, A inverse is equal to minus A over 1 minus a. So for this inverse not to have or to return an undefined value or indeterminate value, then the numerator must be equal to 0. So we can just say 1 minus a equal to 0. So and then the value of a, so a goes to the other side. We have 1 equals to a, or a equals to 1. So when a equals to 1, so if I put 1 here, 1 minus 1 is 0. Anything divided by 0 will be undefined. Anything divided by 0 becomes undefined. So this is the value for which the element r has no inverse when a is equal to 1. And lastly, the last question, we have to find the inverse of 5. So finding the inverse of 5. So we just come here and plug in 5. Anyway, we're seeing a, so we plug in 5 directly. Now, this is not the only way to do this. So in the second example we're going to be doing, so we look at the other method to solve questions like this. When they give you outrightly that, okay, this is the equation, and then you have to find the inverse of a particular value. So what do you want to do? All right, so since we've gotten our general formula already, it's just to plug and play. So remember, if you got 3, so I have a inverse should be equal to, so this is minus 5 all over 1 minus 5. So minus 5 over 1 minus 5, that's minus 4, and minus cancel out minus. So my final answer simply becomes 5 over 4. So this has to be the inverse of 5. I hope this makes sense. So let's look at our last example, and then we can call it a day on binary operation. Okay, so the next example, a binary operation, delta, is defined on the set R of real numbers by n delta n is equal to n plus n plus 12, we have to find the inverse of 5 and minus 4. So we have to find the inverse of 5 and minus 4. All right, so just like what we said in our previous example, so for the previous example, you can see we're already given the, what's it called? We're given the operation already. So the only thing that we needed to do was just to slot in and solve our question. But for this one, um, we have to write our equation or the equation how to find the inverse of any quantity. So we already know that a star, okay, since we are given delta here, so let's use delta. So we know a delta, a inverse must be the identity element. So since we're not given the inverse of a, neither are we given the identity element. So definitely we have to find the identity element before coming to use this. Also, how do we find the identity element? We can simply say a, again, delta e must be equal to a. So we try to do for 5, and then we do for minus 4. So for 5, this becomes 5 delta. Now, since if you write 5 inverse here, it has a mathematical value. So let's just assume a value. We don't know what the inverse of 5 is. So we don't want to write 5 to the power minus 1. That has a value. So let's just assume the inverse of 5, or this inverse here, would be k, or m, or y, or any other value you want to use, you same fit. So 5 delta k must be equal to e, and if 5 delta k is equal to e, then definitely you can come here and say 5 delta e will be equal to 5. So of course, since we don't know what the identity element is, so let's try and find the identity element first, and then after finding the identity element, we can now find the value of k, which is the inverse of this number that is here. So without wasting much time, let's do that. So anywhere we see m delta n or 5 delta e, we want to write it in this way. So we want to write what I'm having here in this way. So you can see my m becomes 5, and then my n becomes a. So I can just write 5 plus e plus 12. So this expression here is what I've listened. So must be equal to 5. So remember, this is 5 delta e. 5 delta e, I've had 5 plus e plus 12, n plus n plus 12, then is equal to 5. What am I looking for? I'm looking for the value of e. So e has to be equal to, so 5 goes to the other side, becomes minus 5 minus 5, that's 0. And then 12 goes to the other side, becomes minus 12. So the identity element here is minus 12. And then since I know the identity element already, then I can come here and find the value of k. So I can simply say, so let me try and section this. So let me write underneath it. So 5 delta k, where k is the inverse of 5, will be equal to minus 12. Again, use this operation that's been defined here. So we have, so my m is 5, my k is n. So 5 plus k, 5 plus k plus 12 must be equal to minus 12. Okay, so 5 plus k plus 12 equals to minus 12. So how do we arrive at this? 5, from the definition, m is 5, n is k. So, and when we have something written like this, it has been defined by m plus n, so we have to say 5 plus k plus 12. So that's why we have what is written here. Now what do? I take 12 to the other side, I take 5 to the other side. So this becomes k. Now 12 is positive here. If it goes to the other side, it becomes negative. Minus 12 minus 12, that's minus 24. 5 on the other hand goes to the other side, becomes negative already again. So minus 24 minus 5, that gives us minus 29. So the value of k is minus 29. So what do I need to combine to 5 that gives me the identity element underneath this operation? So the value or the answer is minus 29. So quickly, let's find the inverse of minus 4. Now, since it is the same operation that is here, definitely both values will have the same identity element. Or let's just test to see whether it is true or not. Okay, so let's see. So first of all, let's have our identity element. So minus 4. So this is for question. So let me do a line here so it doesn't confuse you. So minus 4 e must be equals to minus 4. Okay. Um, Again, use this expression or operation. So minus 4 becomes n and e becomes n. So we have minus 4 plus e, minus 4 plus e plus 12, and this must be equal to minus 4. So minus 4 goes to the other side, becomes minus 4 plus 4, because this negative sign changes to positive. And then we have e. Again, we still have 12 here. So 12 goes to the other side again, so it becomes minus 12. So you can say they have the same identity element because it is the same operation. So definitely they should have the same identity element. So definitely we can now use that to get the inverse of minus 4. So how do we do that? We simply write minus 4 delta. So again, let's call the inverse of minus 4, let's call it y. So this must be equal to the identity element minus 12. So using the operation true, we have minus 4 plus y plus 12 is equal to minus 12. Okay, so minus 4. Okay, so we have to take this to the other side then. So taking 12 to the other side becomes minus, so that's minus 24. Taking minus 4 to the other side becomes plus 4, so that's minus 24 plus 4, and then our final value has to be minus 20. So the inverse of 5, we got it to be minus 29, which is k, and the inverse of minus 4, we got it to be minus 20, which is y. So let's do one more example to see how well we understood this particular concept. Okay, so for the last question, we're told the operation O dot is defined on the set A equal to PQRS. So PQRS are the members of set A by the table below, this table that will be given below. So we are to determine the inverse of each element of A under the operation O dot. So we are to determine the inverse of each element of A under the operation O dot. All right, so without wasting much time, we're going to be doing the same thing we did when we encounter this problem under our identity element. So what do we do? So again, write our first two equations. So we already know. So I'm just going to be using a letter here. Normally I'm supposed to use a o dot forever. But since we're dealing with PQRS, so why not start using that immediately? So here I'm going to be starting with, so I know that P O dot. So now I don't know what the inverse will be. I know that P dot O dot, the inverse, must be equal to the identity element. And if this is true, then I can say P O dot, the identity element, must be equal to P itself. So this is for P. Write the same thing for Q. write the same thing for R, write the same thing for S. Where did I get this from? We already know that O dot A inverse must be equal to E. So which is the first thing I've written here. Since I don't know what the inverse of E is, so that's why I've written it as a dash here. And how do I, and also I don't know the value of A, so that's why I just wrote E here. Now for the second one, we have P O dot, okay, so second one, where did I get second one from? So simply by saying A O dot, so E must be equal to A. So these two values is what I want to use to solve the table to define my identity element first and also my inverse property. So let me try and clear this. So we'll find the inverse property first. I say in the inverse property, we'll find the identity element first. So after finding the identity element, then we can use that to find the inverse property. Okay, so let's write for P. So P O dot. So what am I combining with P? That gives me P itself. What am I combining with Q? That gives me Q itself. What am I combining with R? That gives me R itself. And lastly, what do I need to combine with S? That gives me S itself. Okay, so P O dot dash equal to P, Q O dot dash equal to Q, R O dot dash equal to R, S O dot dash equal to S. Okay, so first thing first, let's look at the table. Of course, this is the column, this is the row. But since I've written just the column, this right hand side, so let's assume that this is my column side. I've written the column on this side here, P, Q, R, and S. So what am I combining to, what's it called? To what to get me exactly P? Of course, the data that are inside here. So let me change the color of this so this can make sense. So these data that are inside there from this point to this point is what I want to be looking at. So now, since I'm dealing with the column, first column, P here, so I have to check the row corresponding to it. So where can I find P? I can find P around there. So it must mean I'm combining this P and then this R together. So P combining with R to get me P. So that means my identity element for the first one is R. Okay, move on to the second one. Q, what am I combining with Q to get me Q? So you can see I'm seeing Q here again. Abi? So if I'm saying Q here, that means I'm combining Q to R. So my identity element for this also is also R. What am I combining with R to get R? Again, R dot R, Abi O dot R rather, to get R. So again, my identity element here is R. And what am I combining with S to get S? So again, it is still R. So you can see that from this expression, my identity element is given as R. So since I know the identity element now, then definitely I can use this to find my inverse element. So let me just clear this. So clearing this, we'll have enough space to work to find our inverse elements. Remember, my E is equal to R. So how do I now find the inverse? So we already know from this expression I've written at the top right corner. So we already know that A dot A inverse will be equal to the identity element. So this time around, so let's write P O dot dash. What do I need to combine to P that gets me? So what's the identity element? We said the identity element is R. For Q O dot what do I need to convert to get me R again? So again, R O dot dash to get me R, and then S O dot dash to get me R also. So this time around, let's see. We want to be getting R now, R. So we start with the column again. So P now, so where is my P? So you can see my P is around there. So where am I saying R? So I'm saying R here. So what am I combining with P to get R? So it means I'm combining P and S together. So P and S. So my identity element, or my inverse property rather, for P is S. So P O dot S gets me R. So how about for Q? So Q, where am I saying R? I'm saying R here. So this is R. So what am I combining with Q? So Q, O dot Q is getting us R. So Q, my inverse property for Q is Q. All right. Now for R, what am I combining with R to get R? So you can say this is R here. So definitely R and R. So again, this is R. So by the time you combine R and R together, I'm getting R. So definitely it must mean my inverse is R. And lastly, for S, so what am I combining with S to get R? So you can see this is what I'm having here. So this is R and I'm combining S with P. So this is what I am having here. All right, so this is how we find the inverse property of a binary operation. So we started the series by talking about the meaning of binary operation, where we looked at how to solve basic questions underneath binary operations. We also talked about the closure property, the commutative property, the associative property, the distributive property, the identity element, and in this video, we've been able to do justice to the inverse property. So, if the concept is still not clear, you can just drop, perhaps you have a question you want to ask, you can drop it in the description box and then it will be attended to. So remember to share the video, remember to like, remember to what's it called? Write your comment in the description box. Peradventure you have any issues or concern concerning this topic. So thank you for watching. God bless and bye bye.